class, what we're working on this today, as far as exam review, is trigonometry. So this was the very first unit that we did in the course, and it's something that you saw in grade 10 as well. So as the review goes on, you have the blank note in front of you, and you can just add to it as we go. If I do happen to go a little bit too fast, you can ask the teacher to slow it down, or maybe some person could volunteer to do that so the teacher can keep working on what they're doing. Okay, a couple different things. First of all, two different things that we need to be able to do, basic things. And this is even without a triangle at first. Okay, so the first thing is to find an angle when given a ratio. And the second thing is to find a ratio when given an angle. And in both these cases, we're using our calculator to do this for us. Now, when we're talking about a ratio all the time through trigonometry, what we're talking about is a relationship between certain sides in a triangle in relationship to a certain angle, which we often call theta. Okay, and when we're talking about a ratio, we're taking one side and dividing it by another side. Okay, so that is what they're talking about when they're talking about ratios. Now, because this is calculator, what we need to do is we need to bring up our calculator. I'm going to bring up a graphing calculator, and here is mine. And what I'm going to do with mine, the RAM has been cleared. However, it's not ready yet to do any calculations with trigonometry. All calculators have to be set to degrees. So on a graphing calculator, I'm going to go to the word mode, and then you notice it has many different items down here, but if you notice the third one down, it's set to radians, and to the right of that is degrees. So I need to have degrees, so I'm going to hit enter, and now you can see the calculator is set to degrees. It will stay at degrees unless I clear the memory of the calculator. Okay, so I'm just going to quit that screen and have it here. So when they're talking about tan theta equals this decimal, and notice it's 4 decimal places, what I'm going to do in my calculator is I literally am going to make the calculator find that angle for me. And the way I do it is when I'm finding an angle, I need to do the shift or a second function on all calculators. And I'm doing tan because that's what it says, tan, and I'm actually entering in that decimal, and I hit enter. When I do that, I see that I end up with 68.72, a whole bunch of different decimals. So I'm only interested in up to the first decimal place when I'm finding an angle. So the way that I would write this down on in my notes, if I was doing this, so first of all, let's bring up a pen. So I'm going to find theta. It equals the tan inverse. And when we're talking about inverse, we use a little -1. And it's this decimals, 2.5. And sorry, I'm using my tablet, which I'm not the greatest at. And notice my calculator said, I believe, and I've forgotten already, 68.7. Oh, touched the wrong thing. 68.7, and it is degrees, so I need to put degrees here as well for communication marks. Okay, so it's really that simple. It's just remembering the keystrokes. So if this seems really strange to you, then you maybe need to put your keystrokes on your help sheet. You might need to use a second function to find an angle. So I'm just going to try that, use second, or it could be shift function. And of course, you can always add whatever you want on your help sheet to help you remember how to do that. Now, the next part is a little bit easier because what it's doing is it is finding the ratio. So in other words, this time I have the angle and I want the calculator to find the ratio between the two specific sides, and the two sides is adjacent and hypotenuse. So with this, when I bring up my calculator, it's actually even easier than the last one. I just hit cos and then 80. Now notice there's a bracket here. You can close it if you want. Because I'm not going to be adding anything or multiplying by anything at the end, I can leave it like that. And notice I end up with a decimal. For this, I want to make sure that I actually use 4 decimal places. And the reason for that is because then I will always be accurate to 1 degree. Okay. Also really watch too that you remember how to round. Now in this case I don't have to round because after the number 6 it's the number 4, so it's going to stay as a 6. Okay, so let's bring up again the writing utensil and up to the spot. And so it's going to be 0.1736. Now I showed you on the graphing calculator the keystrokes for these, but your calculator might be slightly different, so make sure you know how your calculator works. So in other words, the calculator you're going to use for the exam, make sure that's the one you're practicing on. Also, what we did in this grade 11 course is we did primary trig ratios, and that's the SOHCAHTOA. Now, first of all, you can only use SOHCAHTOA if you have a right angle triangle. If you don't have a right angle triangle, you better not use it because it's automatically wrong and I'm not going to even look at it. Okay? Now, the whole point of SOHCAHTOA is it's just a way to remember 3 mini formulas. These are 3 formulas. That's why they made you memorize it. And you can use SOHCAHTOA to find both angles and side lengths. So what we're going to do is we're going to do 2 examples very quickly together. And what I've done along the side, the right-hand side, is I have also put the steps, and you have those steps in your note already for you. So if I look at the first step, it says label the triangle. We're labeling the triangle in accordance to whether we're talking about the hypotenuse, the opposite, or the adjacent. So normally we start with the hypotenuse because it's directly across from the right angle, so that's the H. Then we have our angle. This is the one we're trying to find. So directly across from it is our opposite, and that means the other side is our adjacent. Okay, now you don't have to use arrows if it becomes very cluttered and your brain doesn't like that. All right, so the next thing it says, underlying given sides with SOHCAHTOA. So I'm going to start with SOHCAHTOA. Here it is. And the sides I have in this question are the hypotenuse, because that's the number 12. So if I underline all the H's, and the opposite. And you can see the one that has the 2 underlined, in this case it's so, that is the one that I'm going to use. Okay, so that is my formula. So I'm going to write down my formula now. And that formula is going to be sine theta equals opposite over hypotenuse. It's still sine theta because that's what I'm trying to find, equals opposite, which is the 10, and hypotenuse, which is 12. Now, often with trigonometry, we would cross multiply. But the problem is here, this is very similar to the very first question that I gave you. And that is, if I go back up, you can take a look at it. So here it is here. It's almost exactly the same, except this is a decimal. So what I'm going to do is I'm going to change this 10 divided by 12 into a decimal literally by dividing it. So when I do that, and we'll just bring up the calculator, or you can do it in your head, it doesn't matter. So 10 divided by 12, and you can see that it's decimal 8.3 repeating. Again, I want to keep 4 decimal places in order to be accurate. So this time I'm going to write 0.8333. Now that's not my angle, that's the ratio sine theta. So what I need to do then is I need to take my calculator and take the inverse of that. So theta in this case is going to equal, and if I bring up my calculator again, I'm going to go shift or second sine this time, decimal 8.333 equals. So I end up with 56.4 degrees. So 56.4 degrees. Okay, so that's how I would find an angle. The next thing that we're going to look at is finding a side length. Now, when we're finding a side length, we're actually using the exact same steps. So that doesn't change. It stays the same. So this time, again, labeling the triangle, and this time I'm not going to draw arrows. I'm just going to do it. So here's my right angle. So this is hypotenuse. This time my theta, I know it, it's 33 degrees, so 5 is opposite, and my x is adjacent. So again, what I'm going to do is I'm literally going to take my SOHCAHTOA, and I'm going to clone it and bring it down here, and hopefully it stays for me. Yes, it did. And I'm going to underline what I know. I only know 5, and 5 is my opposite side. But I want to find x, which is the adjacent side, so I'm going to underline it as well. And when I do that, you can see the two that are underlined this time is TOA, so it's the tan. So that tells me that is my mini formula that I'm going to use. So I have tan of theta equals opposite over adjacent. Okay, that's where we get the OA from. And now we're going to substitute our information in. So we have tan, this time we know theta is 33 degrees, equals opposite, which is 5, over adjacent, which is x. Now remember, tan of 33 is actually a number. You can change it to a number if you want right away, or you can leave it the way it is, and now we're going to cross multiply and then divide. So I'm just going to move the screen down a tiny bit or up a tiny bit for you. So now what we're going to do is I am going to cross multiply because that way I don't have to write a million decimals. So I'm going to go x times the tan of 33, and it's going to be 1 times 5, which is 5. Now remember, I want to get x by itself, so I am going to divide both sides by the tan of 33. And when I do that, it disappears from the left-hand side, leaving me only with x. And again, we're going to take our calculator and actually calculate what our x equals. So x equals, and up comes our calculator. And I'll just move it over here so we can see it a little bit better. And so we're going to do 5 divided by tan 33. Again, make sure you know the keystrokes on your calculator. So here it's approximately 7.699. If we round it to 1 decimal place, the 9 is going to force the 6 up to 7. So it's going to be 7.7 is my answer. And I would also then check to see whether there are any units. Now, in this case, I didn't put any units on my side length, so I would just leave it as 7.7. If you want to put units, then you could just put the word units. Okay, so that was part 1, and next we're going to be doing part 2.